So hello and welcome all for our 10th webinar today under the project, which is a knowledge sharing series. And the webinar today is also again on a very important topic, which is about cloud standardization and interoperability standards. And today we have two very, what do you say, experts on the topic. Our moderator today is Mr. Udyan Banerjee, who is an engineering graduate working in Indian IT industry for almost 40 years in different capacities, and is holding currently the position of Secretary in Cloud Computing Innovation Council of India. He's also an advisor to TSDSI, which is our partner for this project and also the host for the webinar series. Mr. Udyan has 4 patents on his name and several publications in international journals, and has been a speaker in many international conferences. So, welcome, Mr. Udyan.
Thank you, Sachin.
And we also have, another great expert, Professor Dinkar Sitaram. And I was looking at his profile, and I have picked some, important elements. So he's a PhD in computer science from University of Wisconsin Medicine from 1984, and currently he's a professor at Department of Computer Science and Engineering and heading Center for Cloud Computing and Big Data. In past, he has worked with companies like IBM and HP. He has over 50 publications, and I was looking at his Google scholar profile, and it seems like most of the publications have a lot of citations. Apart from doing publications, he has around 16 US patents, recipient of many awards and author of many books. Relevant to this topic today, he has authored a book on cloud computing. Apart from other things, he is also chairman of Standards and Interoperability Working Group of the Cloud Computing Innovation Council of India. So thank you, Professor Dinkar, for joining us today. I think we'll all looking forward for hearing from you. So I now invite Mr. Udyan to introduce the topic and share why are we doing this.
Yeah, thank you, Sachin. Yeah, so any new technology which comes in form of a proprietary solution, but over a period of time, for it to become widely usable and it reaches stage where organization can adopt it with ease. Multiple solutions from different vendor has to work together. Application has to be portable across these platforms, and cloud computing is reaching that area where the interoperability and portability becomes extremely important for organization to adopt it in large scale. Professor Dinkar and myself, we have been working closely as a part of the Cloud Computing Innovation Council of India, and he is an acknowledged expert in this subject and has done a lot of work in establishing interoperability and standards. So I think he is going to talk about why and what is the importance of interoperability. What are the different use cases on which interoperability is crucial? He's going to talk about some of the work that has been done as a part of his university and also as a part of Cloud Computing Innovation Council. So, Professor Dinkar, I hand over the podium to you. Please, let's have an exciting presentation from you.
So before you begin, I just want to make a housekeeping announcement. So through this webinar tool, we also have questions that we can take from the audience. So we normally take questions in the last, but I invite the audience, as they have a question, they can type in and I can assign them to Professor Dinkar. So feel free to type in your questions using the questions tab, and Professor Dinkar would answer them once he finishes his talk. So over to you, Professor Dinkar. Thank you.
Okay. Thanks, Sachin. Thanks, Udyan, for that introduction. Thanks very much. We'll try and make this It's an interesting topic, so try and make it an interesting session. Oops, sorry, what happened? Okay, let me see. Yes. So the cloud computing is of course got a lot of mileage, And you may have heard of infrastructure as a cloud and so on and so forth, but I don't know if you've heard of homework as a service, and certainly not about interoperability for that. So first of all, my talk is going to be divided into three parts. So first of all, we'll be talking about why interoperability is important, and also I'll give a brief. We are working on two parallel tracks, and I'll give a brief overview of the architecture and the motivation as to why we are working on those two parallel tracks. Then towards the end of the talk, we'll have demos of what we've done so far in PS University and as part of the Cloud Computing Innovation Council on both these tracks. So the major reasons for interoperability, first of all, there is vendor lock-in. So if you sign up with a cloud provider, one of the inhibitors is that enterprises are afraid that they might lose control because they cannot move from that cloud provider easily to some other cloud provider. So the vendor lock-in, of course, is not good for customers, but I argue that it's not good for vendors also, because if the customers feel they're free to move, they are more likely to pick up cloud computing. And so essentially, I believe that standardization is good not only for customers, but even for vendors also, as it will grow the market. So vendor lock-in is a major reason for that. So interoperability, of course, will be crucial to digital India because the governments have signed up different cloud service providers. And, there might be apps like Digital Locker and so on, which may be implemented on multiple cloud providers. So there has to be some level of interoperability, sharing, etc., among all the providers. Otherwise, these will again become silos, and there won't be any interoperability between them. So globally, not much is being necessarily done to address this problem because of legacy. India, we can address this problem with urgency. So these are two reasons. Then the other thing is there are multiple use cases where having interoperability between clouds would be very useful. Say, for example, in government departments, there are times when the demand for a service peaks. And so, for example, in the income tax or service tax, etc. So if you look at the slide which is being shown, the income tax provider, which is service one, running on a particular cloud service provider, may get overloaded. And so it may be desired to offload some of that processing onto some other cloud which is less loaded. This may be a community cloud and not the native cloud of the income tax provider. So this way you can guarantee that even if there's a peak and it's, you can still get good performance and people will not be frustrated. Another use case is, this is more to mobile computing, is that if you're moving from one place to another, then the data that belongs to you can travel with you. So if you're moving to from one location where you are there to another location, and this again requires that if you're going from the domain of one cloud to another cloud, that these should be interoperable. A third case is guaranteed availability. So I may have a service which is running in one particular cloud, and if that cloud crashes or large parts of that cloud crashes due to some disaster, such as a tsunami or something, so it would be good to be able to resume the service in a completely different cloud in a transparent manner. So that is a third use case, to keep the service running even in the case of disaster. A fourth use case is, of course, multiple applications working together, such as when we want a passport, we would need a police verification, or at least we used to need a police verification, and things like that. So for these kind of cases, it's good if the multiple clouds, if these are implemented as services in multiple clouds, they should be interoperable so that data exchange between the clouds is easy, and it's easy to run a distributed application which actually runs on multiple clouds. The use case number 5 is service continuity. So I may want to, just as part of my what do you call it, regular strategy. I may want to move some service from one cloud to another cloud for particular reasons. Because say the second cloud has a preferable cost structure or whatever it is. Or it may be that I want to offload, move some processing from my cloud, which is a private cloud, to a public cloud, because there's not security considerations, so on may not be there. So in that case, again, if the two clouds are interoperable, then moving the service will be easier. Whereas if the two clouds are not interoperable, then moving the service will be difficult. And finally, a more futuristic case where I have the possibility of, if I want to run a cloud service or do a transaction, then I can look at multiple clouds and I can see which cloud I can have for each application. I can have parameters as the availability, the bandwidth it needs, the security, kind of cost structure that I want. And then based on that, I can pick one of the multiple clouds in order to, decide where to run my application. So as we can see, there are a large number of reasons ranging from vendor lock-in to the futuristic kind of applications that we want to build. So these are all reasons why we would like to have interoperable clouds. So what are the barriers to that? So currently there are many standards, and we would like to develop a unified set of standards that can support some important use cases. So we talked about some of the use cases which were there earlier. Those are actually from the Cloud Customer Council, and also some of them are in the HC standards, where these are important use cases that people would like to do. So our approach has been that what we want to do is we want to be use case driven. So we want to take a use case and then identify standards that can implement the use case and then implement a unified set of standards. So to make this clearer, so essentially what do we need? What we need is, first of all, a single set of standards. We don't want to say that, okay, there are some 20, 30 standards, and you go and you integrate these standards, because integrating all these standards would be a nightmare, and that itself would be a considerable effort. So you want a single kind of unified standard. That single unified standard should provide interoperability and mobility across multiple clouds, so that we have the widest possible choice of cloud service providers. The software should not be vendor specific. So right now there are many vendor specific solutions. So what that would mean is I'm simply locked into the vendor's interoperability software instead of being locked into the vendor's cloud. So preferably it should be open source. And importantly, as I said, these standards, they should support some useful use cases. That is, the important use cases, like, for example, offloading load, etc., etc. These should be doable through the standards. So what is it that we are currently working on? So our initial thing, since the standards have not yet completely fructified, so what we are saying is we provide federation for OpenStack. So we'll create software, we'll enhance OpenStack in such a way that it can automatically federate with other OpenStack clouds. And this would provide an incentive for other vendors to federate, to create open standards and so on. So the other thing is that many vendors, they already provide OpenStack APIs. So OpenStack APIs have kind of become like almost a de facto standard. They're not a officially blessed standard, but since many of them provide OpenStack APIs, we can leverage these OpenStack APIs to federate OpenStack with other clouds as well. In the long term, their standards activities are ongoing. One which we think is important is the IEEE Intercloud NIST effort, since it involves two major standards organization. And we are building this OpenStack federated cloud with the idea that it should be eventually easy to extend it to be compatible with the IEEE Intercloud NIST architecture and also with HC. So we are trying to provide solution which in the future should be easy to migrate to the two standards that we think are emerging and that are important. So now I move on to the demo portion of the slides. I will first of all show our OpenStack demo and follow that up with the IEEE Intercloud demo, since these are the two standards that we're looking at. Oops, sorry.
Right now, Professor Dinkar, we can only see, the usual view. So I don't know if you are having the right window in the.
Yeah, okay. Can you see the QuickTime Player now? It's right now dark, but can you see that?
No, we cannot see anything right now. So I think you need to select the right application to show,
Okay.
because, yeah.
So is it visible now?
Yes, it's visible now. It's visible now. Yes.
Okay, good. So first I'll talk about what work we're doing in OpenStack Federation. So these are some of the students who are working on this, and myself and Professor Sudhindra who's doing that. So we'll talk about the architecture, and then we'll talk about. We'll talk about the architecture, and then after I talk about the architecture, we'll show various things, such as how you can look at federated resources. We have built a federated image store called Glance, and a federated object store, which is in OpenStack, the object store is called Swift. And we have a federated object store. What I mean is that if you have multiple OpenStack clouds, then the objects in each of those clouds can be viewed as if they're objects of one cloud. Then I show how from a local one cloud you can create an instance in another cloud. Then following that, I'll talk about how we can implement one of the use cases we talked about. That is, if there is increased load in one cloud, then automatically VMs will be created in another cloud in order to offload the load. And then finally, I'll talk about some of the ongoing work, such as automation of backup and disaster recovery and monitoring distributed resources. So again, this is our motivation for doing this work. And so first, as I said, we'll talk about the architecture. So this is a high-level architecture of what we have. So on the left-hand side, we have got an OpenStack cloud. And as many of you may know, an OpenStack cloud is a collection of services. There is a network service which creates virtual networks in the cloud. There's a compute service which does things like create VMs and containers. There is a block service called Cinder, which creates logical volumes, which creates virtual disks. And there's an object store, which is Swift, which can be used to store objects, such as If you're familiar with Dropbox, then for images, etc., etc. So this is on the left-hand side. You see another one of the OpenStack cloud, and in the thing called remote cloud, you're exactly the same thing. We also have a networking service, an image service, a compute service, a block service, and an objects store service. So at a high level, what we actually do is that we federate across the multiple clouds. So for federation, first of all, there's a security viewpoint. So for the security viewpoint, we assume the two OpenStack clouds have something called Keystone Federation, which is a standard feature of OpenStack now. And what Keystone Federation does is it federates the user IDs, passwords, access rights across the two clouds. Then based on that, what we have done is we federated each service. For example, we federated the networking services so that the networking services spans two clouds. So it looks like a virtual network service which runs across both clouds. Similarly, if you look at the block storage, which is Cinder, which is provides virtual disk. What we've done is we federated the Cinder service in the two clouds. So it looks like a unified Cinder service. To the user, it looks like a unified Cinder service which can create logical disks either in the cloud on the left-hand side or the cloud on the right-hand side. It looks like a virtual disk service which kind of spans both clouds. And the way we do this is by, again at a high level, is by using proxy servers and pseudo availability zones. So what happens is that if you're logged into the cloud on the left, then the remote cloud, it looks like a sub cloud, which is called an availability zone in OpenStack of the cloud on the left. So if you've got virtual disks or virtual machines in the right-hand side cloud, which is called the remote cloud, those will appear as a sub-cloud inside the cloud on the left-hand side. And we use proxying, that is, we use interception of requests and routing of requests to make the services appear as if they're just one service. So this is for federating OpenStack clouds. So as I said, we can also use this since many of the other clouds, they offer OpenStack APIs. Our vision is that we can federate, say, Amazon and OpenStack, and also VMware and OpenStack using the OpenStack APIs that Amazon and VMware respectively provide, and similarly for Azure. So this is the second phase of our work. Our confidence is based on the fact that in an earlier phase, we had a slightly different architecture, and we were able to federate Amazon and OpenStack. And in fact, we had presented that at the OpenStack Summit in 2014. So with this version, we don't have at present a demo to show that we can federate OpenStack and Amazon, but we are fairly confident that it can be done using our approach. So this is the high-level architecture which shows what we are doing. And now I'll go into the demo. So this part of the service demo simply shows how you can list resources in the. So we are logging into the what we might think of as the local cloud, the cloud on the left-hand side, and you can see that instances. You can see local instances as well as remote instances. That is, instances which are not in the same cloud. Similarly, if you look at images, you can see that there are images. These are remote images, and the remote images are prefixed by the IP address of the cloud. These are virtual disks, and you can see that there are two virtual disks which are actually belonging to the remote cloud, and there are two virtual disks which are in the local cloud. And over here, these are object containers. Again, we can see that there's a local object container and a remote object container. Both of those are visible from the local cloud. So the resource of the remote cloud, they kind of appear as if they are a sub-resource to the local cloud. The only difference is the name is prefixed to the IP address. We'll now talk about image management. So image management is important because if you've got multiple clouds, then what happens is that with multiple clouds, then image management becomes a problem because if you upgrade say one image, you may in one cloud you may want to upgrade another image in another cloud, etc., etc. So our model is that there will be a central repository of images, which is like a golden repository of images, and those can be transferred to remote clouds. So in we are providing two ways of creating images. One method of creating images is to directly copy images from our cloud into a remote cloud. The second way of doing it is that if a VM is running in the remote cloud, or if a VM is running, sorry, not necessarily in the remote cloud, you can create a snapshot of the VM in the remote cloud that will allow you to do VM migration. So here there's a technical difficulty as to, in the earlier slide, there's this mention of a technical difficulty with doing that and how we overcame that difficulty. So here we're logging into the image server of both of these things, and these are the images which are available. So here we are uploading an image from our local cloud to the remote cloud, so that we have a central repository of images, and we are going to upload that to a remote cloud, so that there is no discrepancy between the VM image I have here, or the image I have here, and the image in the remote cloud. So as you can see, the image has been, in the previous slide, it showed that the image had been there in the remote cloud. So you can see that there's the same image is there on both the local cloud. By verifying the ID of the image and things like that, we can verify that the same image is there in the local cloud and the remote cloud. This is a what do you call it? The second part of this is a use case which is important for for VM migration. So one common method of migrating VMs is to take a running VM and to snapshot the VM to a remote cloud, and then the VM can start running in the remote cloud from the snapshotted image. So this is what is shown over here. So that we have a VM which are shown over there, and we are going to snapshot it to the remote cloud. So again, we can verify that the correct image was created on the remote cloud, and we can start running the VM from this remote image. So of course, we also have the ability to delete images in the remote cloud. So when the image is no longer needed, it can be deleted from the remote cloud. So those were the image VM image deletion, which is very important because essentially the image contains all the software you need, and if there are two different versions of the image, they could have slightly software, and then that could be a problem because when you run those on the local cloud and the remote cloud, then there can be some incompatibility that arises. So now I'm going to show how we can create and delete objects in the object store of the remote cloud. So this is important because in open the object store is the location where images are created. So this Swift demo is actually the foundation for the glance thing that we showed earlier, for the image thing that we showed earlier. So here we can show that if you have images and photos or whatever on a remote cloud, we can look at our files, data files and whatever. We can find that from the local cloud as well. So you're logging into the local cloud, and this is again a remote cloud image, and you can see that we can list the local containers as well as the remote containers, and you can of course delete the remote containers also. You can list their contents. So now we will show how we can upload an image to a remote cloud. So in this case is just an actual photograph, and we want to upload this into the remote cloud from our local cloud. So the object has been uploaded to the remote cloud. So this is another interesting use case, and that is we may want to manually deploy an instance not on a local cloud but on a remote cloud. So we'll first show how this can be done manually, and after this, the next part of the demo, we'll show how this can be done automatically using a script, so that the load increases, VMs will automatically be created on the remote cloud, and when the load decreases, those VMs will be deleted. And okay, another thing I forgot to mention is that when we are showing this manual image, when we are showing this creation of a VM image in the remote cloud, we'll also show that you can attach a virtual disk which is in the local cloud to the instance which is running in a different cloud. So the idea for this is data security. I may want to run a VM in the remote cloud, but I may not want to copy the data there because security is high. I may want the VM to access the data, but we don't want to copy the data there. So we show both these use cases. Again, it's a small technical detail, and that is that before we can spawn a VM in the remote cloud, we had to create a virtual network which spans both the local cloud and the remote cloud. And so that is what we're doing over here. We are defining the IP addresses of the virtual of the network, and so on, the different parameters that need to be defined for the network. And so now we are creating a virtual network that spans both clouds. Without that, we can't create, the two VMs can't talk to each other. And as can be seen, when we list the networks, you can see that there is a virtual network in the virtual cloud. Okay, so now we are going to actually create the instance. Okay, so we are going to launch an instance, and from the local cloud, we are going to create an instance in a different cloud. We are giving the instance the name instance 2, and we're going to pick the remote cloud, which, as you can see, has a IP address, prefixing it a remote IP address. And we are going to pick the various parameters such as, what's the image, what is the boot disk, etc., etc., the various parameters of that, of the image, and then we're going to pick the virtual network that we need to put the VM into, and now we're going to actually launch the instance. So if we come back to the local cloud, we'll see that the instance is being spawned in the remote cloud. And now the instance is actually running in the remote cloud. And now, as I said, we are going to attach a volume, a virtual disk from our local cloud to the remote cloud. We are going to pick the volume. The first thing we're going to show is that we can attach a virtual disk in the remote cloud to the remote VM. then we show that we can attach a local disk to a remote VM. So that was attaching a remote disk to the remote VM. And now we're going to show how you attach a local disk, right, to the remote VM. So now we're going to, this is a local disk. As you can see, it doesn't have a remote IP address prefixing it. And so we've now attached it to the remote instance. So here we've logged into the remote disk, and we're going to list the virtual disk which are attached, so as to verify that the virtual disk is actually attached. So this is the console of the remote VM. We're going to log into that. And with the output of the fdisk-l will indicate, not very clearly, that the remote disk has been attached. As you can see from the thing which flashed by the screen, the remote disk was there attached. So the final part of this demo will be auto scaling. So what we're going to do is we're going to create a VM in the local cloud. Then we're going to put a lot of network load on it. That will cause VMs to be spawned on the remote cloud. Then we'll reduce the network load, and the VMs will automatically get reduced. So in order to do this kind of thing, we write in OpenStack, one writes a script using a software which is called Heat. And so first of all, the stack name is simply the name of the script. So what the script does is it monitors the load, and if the load becomes too high, then it will automatically spawn a VM in the remote cloud. So we are logging into the VM in our cloud, the local cloud over here. And what we are going to do is we are going to generate a huge amount of network traffic by pinging 8.8.8.8. Okay, so this ping will continuously generate ping packets, and then what the script R70 does, if the network load is too high, then it will automatically spawn a new VM. And so as you can see, after some time, I think there's a latency of 2 minutes or something. The new VM has been created in the remote cloud because it's prefixed with the remote IP address. Then after some more time, a second instance gets created. And because we are still pinging at a very high rate, the network load is still high. And so after some time, a third instance is generated. So due to the high network load, we started off with one VM in the local cloud. This is the one, and then what happens is that from this VM we spawn by snapshotting VMs in the remote cloud. If you run Noki, which is a monitoring tool, it shows that the number of packets per second is very high towards once we started the ping, and this is what causes the R70 script to keep on generating VMs in the remote cloud. So now the next thing we are going to do is we are going to go to the VM, our original R70 VM. Here in the remote cloud, we are showing that we have logged into the remote cloud just to show that those things are there. And now we are going to log into the cloud, the R70 VM, which is in a local cloud, and then kill the network traffic so that the network traffic comes down. And then we see that the clouds in the remote VM will reduce by themselves. So we now start the network traffic. There are no more pings which are going on. So now, right now, we see that there are still 3 instances, but when we refresh the screen, then you can see that one instance has already been killed, and then the second instance has been reduced, and finally, the third instance is also gone. The third instance was spawned on the remote flow is also gone.
So just a timekeeping announcement, Professor Dinker. 5 more minutes for you to summarize.
Okay.
Is that okay?
Quickly, yeah, I'll then quickly stop this demo. I don't think there's much more I want to show here. I'll quickly talk about IEEE, what we're doing in the second demo, the IEEE demo. Show the IEEE demo. But before that, I think I show the our IEEE. So this was a federated application services demo, OpenStack Federation. We'll talk about the IEEE Intercloud demo. So IEEE Intercloud is one of the major standardization efforts, and as I said, it has now been continued with NIST. And
Professor
we think.
Dinker, you cannot see your screen again. So.
Oh, I see. Okay, I'm sorry about that. Is it visible now?
Yes. Yes,
Okay.
it is visible.
Okay, so the IEEE Intercloud is one of the major standardization efforts going on, and because it is also supported by NIST, the National Institute for Standards and Technology in the US, we think this will get a lot of traction. And the IEEE Intercloud, to summarize, is sort of built like the internet. Is sort of built like the internet. So each cloud is connected by there's a sort of cylindrical thing with a red box is connected by an intercloud gateway to the intercloud root. The intercloud root has intercloud exchanges, and if a request cannot be satisfied by local resources, it is sent to the intercloud exchange, which would recommend a cloud. So each cloud will register itself with the intercloud exchanges, and the exchange, the gateway translates requests from one cloud to another, and the exchange keeps tracks of which clouds are available and what resources each cloud has. So this is in a way similar to the internet, the way the internet works with backbone routing and those kind of things. So what we have done is we have implemented this intercloud architecture for OpenStack. So this is actually the older architecture. The intercloud architecture is right now under revision, and what we had implemented is based on the earlier architecture, but the newer architecture is similar. And so we think that we should be able to take what we are implementing right now with OpenStack Federation and migrate that to the newer architecture. So let me then start the intercloud architecture demo.
I would request you to keep it very brief because
Yes.
we have only 2 minutes, 3 minutes.
Okay, fine. Okay, let me see. I think I'll have to let this play for some time. So,
the screen is not visible again.
Oh, I'm sorry. Is it visible now?
Yes, it's visible.
Okay, so here we have got two OpenStack clouds, and the gateways, the XMPP servers are the gateways. So we are showing both the screens side by side, and we are starting the gateway so that the two clouds can talk to each other. So for this application, we have not integrated the display with the OpenStack UI. We had our own UI for that. We did not have time to integrate the UI with the OpenStack UI. And so these are some of the people who are involved in, including Sujit, who was a student. So we are logging into the gateway. So I think I skipped ahead a little bit. So here we are launching an instance, where we are defining the instance name, the flavor, that is how many and what memory it has, and the image which the OS is running, and so on and so forth. So what happens over here is that when we launch the instance, the first instance, the resources are available in the local cloud, and so there is no interaction with the remote cloud. The instance is created in the local cloud itself. Then we go ahead, and as you can see, if we could come back to the GUI, it shows that the instance has been launched and it's running. And if you go to the OpenStack screen, we can see this instance, which is there. So now the next thing we'll do is we'll launch another instance. So here we're going to launch another instance, which we call demo VM2. And we launch that. So if we go to the console of the our local cloud provider A, then it says that the resources are unavailable. So when that happens, then a message is sent across the intercloud gateway to the second cloud. So as you can see, the second cloud has received a request to create a VM and allocate a floating IP and so on and so forth. And then once the VM is created, then message is sent back to the local to the cloud A with the details of the VM, demo VM2, the IP address, and so on and so forth.
So Professor Dinkar, can we summarize now, because there are some questions from participants, so we will not have time otherwise for that.
Okay, fine. So I think this is essentially what I wanted to show. So I will just pause it at this point and then take the questions.
So I invite Mr. Udin again. If you have a question as a moderator, maybe a difficult one for Professor Dinkar. And also, Professor Dinkar, I have assigned questions to you as they have come to me. In the interest of time, you might want to answer as many, but maybe with a brief response, and maybe you can display your email ID. So if there are more questions coming, they can write to you. So, but sure. Over to you, Mr. Udyan, and thank you, Professor, for these demos.
Thank you very much. So Udayan, are you on mute, or should I answer the questions at this point?
Yeah. So, Mr. Udyan, do you have a question? Okay. So maybe, Professor, in the interest of time, I would request you to go ahead with the questions from the participants. Can you see your questions tab?
Yes. I'll just answer. I think I'll just start with the top question. And okay, so both clouds are on OpenStack. So Mr. Chengappa had the question that both clouds are on OpenStack. Is anyone done on interoperability with OpenStack and VMware and OpenStack and AWS, etc.? Yes. So actually, in this in the earlier version, so we had an earlier version of this with a slightly different architecture. I won't go into architectural details because that will require a lot of time. But in that case, we had been able to show interoperability and federation between OpenStack and AWS, and also OpenStack and VMware. But we have not done that for this architecture. But because of the earlier experience, we feel more or less confident that that can be done. So now I'll take a question from Mr. Vishnu Ram. Is scheduling a process or task possible across local and remote? Is load balancing possible across local and remote? So the answer to that is absolutely that's possible. So that will require a couple of things. That will require the monitoring infrastructure. So right now we are working on a federated monitoring infrastructure that is span both the local and remote cloud, and that is not complete yet. So when that is complete, then the standard OpenStack load balancer will be able to get statistics on the load on the different clouds, and then it will be able to do that. So that is absolutely possible. Then another question from Mr. Vishnuram, who is standardizing the interoperability test cases? So that is the activity which we plan to take up with inside CCI in collaboration with TSDSI when we have the federation more done. So because the federation will determine what are the interoperability test cases. So we had to determine what are some of the common customer use cases like bursting of VMs across the highly loaded clouds and so on. And then based on that, we can do the interoperability test cases. So the current strategy is that CCICI and TSDSI will together define those. And then again from Mr. Vishnuram, could you please detail the contribution of CCICI in this area of cloud standards interoperability? So we have been doing the architecture and implementation work with review on use cases and those kind of things on CCICI. And CCICI has many experts on areas like security, storage, and so on, whose expertise we have leveraged to do this. Then from Mr. Chengappa, what is the threshold set on the VM for scaling the VMs? Is the heat template based on CPU usage or memory usage? So in the case which we showed, it was based on the network adapter. It was based on the network load in the adapter. But of course, in the heat template, we can also monitor the CPU usage, memory usage, etc., and use that as a criterion for spawning additional VMs. Then from Mr. Andreas Summer, does the work on cloud standards interoperability also consider security, redundancy, and resiliency aspects? Examples are hosting in secure data centers, meeting security standards, and so on. So what we have assumed is that there already is a security infrastructure which will standardize access rights and user rights. So the question that is being asked is more on the nature of SLAs. That is, do I have an SLA in terms of redundancies, resiliency, and so on? So that is on our list of things to do. We have not tackled. There could be SLAs also in terms of response time, etc., etc. And those are things which we have to tackle, plan to tackle in future, but we have not yet done that yet. So again, yes, from Mr. Andreas Sommer, the privacy aspects. So yes, we are aware that those aspects have to be addressed. We feel we can address that inside this architecture, but those have not yet been addressed. Then from Mr. Jagdish Pampa, please tell us what cloud standards and interoperability standards you referred when you're developing this architecture and application. So currently we are doing federation using OpenStack APIs, and when IEEE standards and so on mature, then we plan to migrate to those. So that's exactly what we are doing. From Mr. Rajendra Prasad, how involved are the Bureau of Indian Standards in this effort and their road plan? So we have been trying to get in touch with them, but as of now, they are not completely involved in this as yet. From Mr. Vishnu Ram, how many physical servers are you using for the demo? So the answer is 3 physical servers. So this has not been done with a lot of scalability testing. So we are looking for funding to both include aspects which were brought up, such as QoS and so on and so forth, and also for getting the infrastructure. And if we do get fundings, then we can scale up the project and have more servers and so on and so forth. So I think those are the questions which were there on the stack, question stack.
Yeah, so maybe still one or two question might come, but
Okay.
I think you have been quite swift in answering, and we are facing a technical problem that Mr. Udin is not able to unmute himself. I'm sure he had a question or two for you, so I don't know
Okay.
if he wants to type down the question. Maybe we can still take it because we still have 3-4 minutes left. So you have been very what do you say, quite fast in answering the questions. So I I still wait for a minute. If anybody has any more questions, please use the questions tab to ask. Okay, so there is Mr. Udin. If you are hearing us, then you may also type your question if you're not able to speak. Okay. So maybe at this point, I would really like to thank you, Professor Dinker, for being very patient in giving the talk and answering the questions. I have shared your email in the chat with
Okay.
everyone. I hope you don't mind that,
No, that's
and
fine.
maybe people will contact you with more questions. In fact, some more have come.
Okay.
So if you have time, maybe you can just answer the last two questions.
Okay.
Yeah. Can you see them?
Yes, yes. So from Mr. Chengappa, can the OpenStack APIs form the base in standardizing the interoperability? So that is our current stance that, okay, we'll use the OpenStack APIs right now as the basis for standardizing, and then later on migrate to other standards. So basically, we can, if we use the OpenStack APIs right now, we can have a very quick implementation of federation between OpenStack clouds. And I feel that will create the incentive for other vendors to take standardization and so on seriously. And then once we have that done, we will then migrate to IEEE and HC and so on and so forth. So from Vishnuram, are the documents or standards draft? So we would have to create it because I think we are planning to collaborate on this with TSDSI. So right now we have a couple of papers, since we are academicians. We have a couple of papers which describe what we are doing, but not really kind of documents or standards that which are in a reviewable form. But since we are planning to collaborate with TSDSI, we'll have to create that, and definitely we will circulate that once that happens.
I think, Professor, there is one or two more questions. Did you see them?
Yes, yes. Okay. Okay, from Mr. Jagdisha saying thanks for the talk. So thank you very much. I'm glad you enjoyed the talk and appreciate your taking the time. Is CCS here or PS working on from Vino Mangat detection of DDoS accounts in multi-cloud? So no, that's not a topic which we are taking up. That certainly is a very interesting topic. We have done some work on with IBM on intrusion detection in single clouds, but not on multi-cloud. That definitely is a very interesting topic and well worth taking up. And from Mr. Rajendra Prasad, how are the efforts of IEEE, IEC, ISO organizations? So as I said, we see that IEEE intercloud is likely to emerge as a standard because it's being pushed by both IEEE as well as NIST, which are well-known standards organization. And of course, IEC, I think, is working with HC. in defining its own standards, and those are complementary, I think, and those will merge.
Okay, so I finally have a question from Mr. Udayan also.
Okay.
So he's saying which is more important, IaaS, which I believe infrastructure as a service, interoperability, or SaaS interop, which is probably service as a software as a service interoperability.
Yes. Okay. So I think that's a very good question. So my feeling is right now there is more demand for IaaS interoperability. So I'll give my reasoning for that. If you look at the cloud things that are happening, there's a lot of migration of legacy systems to cloud. And the other area where there's a lot of cloud, in my view, happening is greenfield efforts, which are not really interested in the hybrid cloud kind of thing. So I think right now, IaaS interoperability is both technically easier as well as I think more in demand than the SaaS interoperability. Though SaaS interoperability is also a very important thing.
Okay, so I hope that answers Mr. Udayan's question, and I would like to again thank you, Professor Dinkar, that you have been very patient and answering so many questions. And since you have been referring a lot many times about your partnership with TSDSI, so I have also shared with everyone in the chat email of Mr. Vijay Madan, who is looking at the standardization efforts at TSDSI. So if anybody has any questions linked to TSDSI, may email him. And thank you again, Professor Dinkar, and I hope with your efforts we see lot of action in this space. And I also thank Mr. Udayan Banerjee for being with us today. Unfortunately, in the last part we faced some technical problems, but we look forward to hear more on this topic, as I understand from TSDSI colleagues that TRAI has asked TSDSI to come up with the interoperability and portability standards. So with that,
So
I thank you.
Yeah, sorry. Go ahead.
No, with that, I thank all the participants. So over to you, Professor.
Yeah, so thanks, Satyan. Thanks very much for hosting this, and thanks to all the participants for their questions and interactions. I felt that was very good, and it's a pleasure to give the talk. And Udayan, thanks very much. Sorry that somehow you got muted at the last minute, but thanks very much for the moderation.
Okay, then thank you all. We are done for today, but look forward for the next month and next topic. Thank you very much.
Okay, thanks very much, and bye.